Hey guys, welcome back. Okay, couple things since the last video. You'll notice the first thing you're going to notice is all the lights are off, and that's on purpose. Secondly, I've moved our camera down here to the lower right corner, and if I click on him, you'll see he's actually pointed right into the scene. Okay, so if we run right now, you can see we're looking straight into the scene. That's really loud. Hang on a second, let me turn that down. I don't know if it's loud on your end, but it was like super loud on my end. Oh, I've got the sound still on. That's one problem. One thing you'll immediately notice, guys, is I've got the first-person camera back up. It turns out as soon as I put it in, it worked fine. So I want to talk about that for a minute. The first-person camera, when we tried to put it in before, when I turned on those triggers, immediately fell through the floor. Whereas when I put in the third-person camera, it did not, under exactly the same circumstances. Now, the reason I believe the first-person camera fell through the floor when I turned on those torch triggers was, initially, you guys remember, we had the torch trigger radius set way too high. In fact, every single torch was encompassing the entire scene. So effectively, the rigid body on the camera controller was getting hit by 300 colliders all at the same time, plus the collider on the floor, actually, which counts as one, so that's 301. And I believe that at that point it just gave up and it couldn't deal with it anymore, and so it only took the first few hits and then just ignored the rest, which is basically why we fell through the floor, because it was ignoring the floor collider. Now, the third-person camera didn't seem to have that problem. Even though we were getting hit by 300 colliders, it seemed to be able to handle it okay. So I'm inclined to think that it's a limitation of the camera itself, not the software, but the scripts itself, rather than an engine limitation. It could be an engine limitation. I seem to remember there was a limit on the number of colliders that could strike a rigid body at the same time. But I went looking for it and I can't find it, so I might be wrong about that. It could just be, yeah, there was a problem. But anyway, we have since reduced the radius of the torch colliders, the trigger on those torches, and right now there's only about 20 hitting the. Oh, in actual fact, there's actually exactly 17 triggers hitting the collider, so it's able to handle that. 17 plus the floor collider. So we've got our much nicer camera system back, the one that I like for now, until we replace it with our own. So there's a few things I want to do here, guys. We are going to work on these torches. You see I've got all the lights off right at the moment, and that's on purpose, but I want to enhance, again, our counter just a little bit. So I'm going to go into the scripts and the UI scripts and the FPS counter. Let's pop that back open again. There it is. Okay. First off, I think I'm going to change this dark green. And I'm going to change it to white. And we're just going to go straight white. 1.0. White is 1.0. This is not yellow. Let's see. Color white. Color white. There we go. Let's go ahead and refactor that. Everywhere it is. There we go. Just because I want to see, I want to be able to see that counter, and dark green just isn't doing it for us. We can't see it. So we'll go from white to green to yellow to red. Secondly, I'll fix that yellow thing in a minute. I've decided I don't really like where this is sitting. It's green all the way through 30 and really down even below 30 until we get down to 20 before it starts getting really yellow. I'm going to adjust this to 40 frames per second yellow at 30 frames per second, and then red as it gets below that. So that means we got to adjust our counter here. So this is going to go from minus 40, and the range here is going to be from 60 to 40, so that's a 20 range of 20. This is going to be 30 frames, so this will be a minimum of 30, right? So we'll subtract 30 off of that, and this is going to go from 30 to 20, so that's still a range of 10. And then this is going to go from 30 down to 0. So that'll be a range of 30, right? So did I do that right? So this is going to be from 40 to 30, 30 to 0. So at 30 frames per second, you're still going to be yellow, right? Because it's going to go from yellow to red as you go down from 30 to 0. So when you hit 20, it'll still kind of be yellowish, but it's heading for the red, and that's kind of more like what we want. I think 40 is still okay, but you're getting down into the green. Anything above 40 would still come up as white, I believe, if I'm not mistaken. So 40 minus 40 is oh, 40 is the low end. Okay, yeah. So then 60 is going to be, yeah, 60 would be 60 minus 20 would be 20, and then divided by 20 is 1. So anything 60 or above is going to be white, straight white, because again, this is ceilinged at 1. So if it goes above 1, it'll still be white. So okay, I think that's what I want. So let's go ahead and just really quickly head back into Unity and make sure that's working okay. We should get a white counter. Yeah, very nice. Yeah, that's better. Okay. The other thing I want to do with the counter, is as long as we're here, I'm going to put in another float, and I'm going to say milliseconds, ms. Okay, actually, let me milliseconds. MSPF, milliseconds per frame. Normally I won't use abbreviations like that, but MS is the standard scientific abbreviation for milliseconds. And I have a science background, so I'm used to MS, and PF is kind of goes along with FPS, right? So I'll in this one particular instance, I'll make an exception and just make it understood that this means milliseconds per frame. Okay, milliseconds per frame is a simple calculation. MSPF equals 1.0f, whoops, 0.0f divided by FPS. That's frames per second, and then you got to get to milliseconds, you got to multiply by 1,000, 0f. Okay. The reason I want to put in milliseconds because frames per second can be a little bit misleading. Like if you're up at 1,000 and you drop even like a fraction of a second, it'll cut it in half down to 500. So there's huge kind of disparity in the upper levels of this kind of thing. Whereas milliseconds per frame doesn't have that problem. It's a linear kind of thing. So let's see, where do I set that? There it is, the text. Okay, so we're going to add in another little section here, plus MSPF. That's totally wrong, MSPF. And then we'll just close off the parentheses. Milliseconds. The reason I'm doing that is frames per second can be a little bit misleading. Come on. But also, the stats panel has milliseconds on it. If you see right here, frames per second, and then it's got a 3.0 milliseconds. So we've got the same thing now, although ours is not formatted properly. All right, I'll reformat that in the next video. I gotta look up how to do it, and I don't want to waste time doing it right now. Let's see. Yellow is red plus green. There's no blue in yellow. There you go. That's the problem. There. Okay. That should fix that. Is that all I wanted to do? Let's go ahead and, whoops, don't hit that button. Let's hit that. So let's see where we're at here. Okay. Let's just fix that formatting. For whatever reason, this is being a pain. FPS plus, put in a space. Thank you. Save. Apparently I'm unable to format strings today. There we go, that's better. Okay, so we got 250 frames per second, 4 milliseconds to do a frame. So there you go. Yeah, that's right, because 4 milliseconds is 250, or 0.25 seconds, which would be 250 frames. Okay. And then according to their statistics, we're not far off of that. Okay, now the reason I wanted to do this, there's a couple of things here, guys. I wanted to get a baseline to know how fast our scene can go. Now, right now, we're sitting about 250, and that's about as good as we're going to get with the scene that we're looking at right now, with no lights going. Notice, however, as I move the cursor, look at this, 20 active lights. Why is that going off? The reason that's going off, guys, is that even though if I come in here, I focus in on whatever I'm clicked on, even though I've got this, the torch is turned off, okay, the torch triggers are off, okay, the sphere collider is still on, and that's why it's, and of course remember the sphere collider, this torch trigger script is attached to the sphere collider. Right, so if we go to the torch trigger, we got the on trigger enter, out trigger exit in this function. So it's causing this to go off, which is causing that thing. Now that's going to cause us problems later on. So under torch toggle, we're going to fix that. So we're going to do a trans. Actually, no, never mind. We don't need to do a transform because this is a component of the torch itself. So get component, and this is, what did we say it was? Sphere collider. Sphere collider dot enabled equals true. Okay. And when we extinguish the torch, we'll just turn it off. There you go. That should fix that problem with the torches being off and yet still showing us that they're on. And it is not. Why is that? Okay. It shouldn't be on, should it? And I've got the, I can see the sphere collider's off. Always something, isn't it? Log quote enter. That shouldn't be firing at all. So let's go see what's going on. See if we get the console to tell us what's going on. I hope those triggers are still firing. Well, that's weird. Why are they doing that? Yep, and they're continually going off. Well, that's super annoying. I got the spherical lighters off. Why would these torch triggers be on? Okay, fine. You know what we're going to do? That's kind of annoying, actually, to be honest. Git component, torch trigger dot enabled equals true. We'll turn off the script itself. False. Let's try that. Let's clear that. Come on, Unity. Pay attention. Let's run that. That's really weird. There's no way those should be running. That script is off. Okay, I wonder if I have to go back. Let's go into the prefabs and the decor and go to the torch, and I'm going to turn them all on. Toggle. And then I'm going to toggle them off again. Let's clear that. What if I have to actually tell it? That's why. I guess. Because it never actually got set. That's interesting. I wonder if that's going to cause us problems later on. I'll have to think about that one. Okay, anyway, yes, we got it working. Probably overkill now. I gotta turn that sound off. Okay, so let's record this. No lights. We have a frame rate of, according to my counter, about 200 FPS. Okay, I'm not moving the camera, notice, so that we can get right back to this exact same spot. And according to the stats counter, it looks like we're sitting right around 300. Okay, that's good. So that's our goal, guys. That's the best we can get at the scene that we've got right now. If we can get back to 200 frames per second with the system we're about to put in, then we're great. We're golden. We're as good as it's going to get. That means the lights are not affecting the scene. Now, we won't quite get back there. I can promise. All right, I'm going to turn the toggles on. So now all the torches are going to be on. So let's go all lights. So right now, according to my counter, we're sitting at about... Oh, it's kind of jumping around. Say on average about... Huh, it really is jumping around, isn't it? Kind of looks like about 40 frames per second. I'm going to set it there. According to the stats counter, we're looking at about... it's also jumping around, but it's kind of setting around 50 frames per second. Okay, so you can see we've lost about 160 frames per second on my counter, which, by the way, it looks like it's working just fine. I like the colors. We've got 19 active lights according to this. Oh, you know what? Come to think of it, I'm going to turn on the lights by default. I think I have them turned off by default. Yeah. Well, I've got a range of 0. Let's give them a range of 15. Not 150. 15 is fine. I want them all on. For this test, I want all the lights to be on. And I think they should all be on at this point. Okay. Doesn't look like it's changed much, really. Actually, it kind of looks like it's gone up a little. So we'll say 50. It's not quite so bouncy either, for that matter. And looks like the stats frame is about 60 frames per second. Okay. So there you go. That's kind of our worst case scenario. All the lights are on. So good. All right. So if we set the default back to 0, and we run that. So at this point, there's only going to be a few lights on, right? So yeah. What we want to do, guys, is in the trigger function. I don't need this anymore. I don't need this anymore. Let's turn that off. We'll leave that on. I shouldn't need that. I shouldn't need that. Okay. So let's talk about the trigger function for a second here. What we want to do is when we're inside the trigger, we want to get a distance to the light from the camera to the light. Okay. And this is one of those deals where I don't want to do it every single frame. I don't want to do, 600 distance checks per frame, right? That's just too many. So, and we don't need to. We only need to do it every once in a while. So I'm going to do an invoke repeating command, and we'll do a distance check method. Distance check. I will start at 0, and we'll put in a property here, distance check time, and we'll make that public. Yes, please. Wow, what is that? Public float distance check time. That way we can adjust that in the editor itself. Okay, now when we exit the trigger, we want to turn that off, right? So I'm going to say invoke repeating. No, sorry. Not invoke repeating, we just did that. We want to do cancel. Oh boy, cancel invoke distance check. Okay. It should be public. Okay. So I'm going to put a private void distance check. So this is the function that's going to get called. We should give this a default of, I don't know, 0.5 seconds every half second. Okay. So a couple things here, guys. First off, we're going to do a distance check. Distance checks, if you use Pythagorean theorem, involve some multiplications, some additions, and a square root. We do not want to do a square root. So, and there's really no need to do a square root, guys. You can take the square of the distance rather than a square root. Square roots are very slow, so you don't want to be be using them if you can avoid it, and we don't really need to use it. So here's what we're going to do. I'm going to make a let's see, what do I want to do here? I think I can make this local, so let's do that. Let's go float distance, and then we'll say distance equals okay, so we need to go from the camera to the torch, right? So we need to get both those things. So just like before, because there's going to be 300 torches, we don't want to do this in design time. We want to do this in, or we don't want to do it in runtime. We want to do it in design time. So we'll do public game object torch and public game object the camera. Let's do the torch. Wow. The torch. Okay. The distance between any two objects is simply going to be equal to the camera, get its transform, and get its position. And then from that, subtract the torch, transform, dot position. And then we'll do the square magnitude, which is a property. Okay. So how does this work? This takes the position of the camera, subtracts the position of the torch. So you get a vector 3 here, right? And a vector 3 has a property, square magnitude, which is the squared length of the vector, the vector 3. Okay, and that's the distance between one object and another object. Okay, the square distance, I should say. Now remember, guys, we won't, whenever we do this, we want to go distance check counter dot instance dot, what did I say? Increment check. Dot increment check. There you go. Okay, that should get us the distance to the from the camera to the torch. And if we run that, we should get some distance. Oh yeah, that works. Except it's not working. Because duh. We need to set in the script, we got to set the torch. So we'll go the torch. And we also need to set the camera. So we'll go to first person camera, which is here. We'll just drop them in here. There we go. So 38 checks per second. Now, actually, if you think about that, that's right, because we set the distance time check to 0.5 seconds, so it's doing twice per second each light that hits the camera, which at this point is 19. So 19 times 2 is 38. So that's exactly right. Okay. Hang on a second. Let me fix that sound stuff. I'm going to turn off the sounds on the footsteps. This is just script stuff. This is not there. I don't want the sound on the camera at this point. Okay, guys, so with the distance checks, we've actually dropped our frame rate down to, say, about, again, it's jumping all over the place, but we'll say about, looks like around 40. And the stats is sitting right about, geez, I don't know, 45. So we've actually dropped a little bit, but that's okay. That's fine. Okay. What I want to do is fix the lights. Okay. There's a lot of components to the torches, right? All these components that we've got going on here. The only one I want to work on right at the moment is the lights, and specifically this range. So, okay, so what we're going to do, guys, is get some let's get some properties going here. So public float max light intensity. Let's see. Then we'll do a public float what do we want to call this? We want two floats. Max light intensity range. Intensity distance. What I'm trying to get at here, guys, is you remember in the design, we don't want the torch intensity. We're gonna vary the torch intensity by distance from the camera. So the farther away you are, the dimmer it's going to get. But we don't want that effect to go right up until you're on top of the torch. We want there to be this buffer distance between the torch and the camera where it hits its max intensity and then stays there right up until you hit that torch. So that's what I'm after right there. I don't think we need a minimum because that'll be the same distance as the radius. In fact, I can set up a private float min light intensity distance. And what I want that to equal is I want that to equal the same distance as the trigger radius. But I don't really want to do that at runtime, so we'll do it at design time. So let's save that. Let's head back into here. Now go to the torch. There's going to be, so we've got our sphere collider, which is set to 0.5. So I'm going to take this radius and I'm going to set that equal to the minimum light intensity distance. Let's just set this to 0.1. And then we'll set the max light intensity equal to 15. Okay? So there's our variables, right? So we're going to adjust this max light intensity, or we're going to adjust the light intensity from max light intensity down to 0 as you go across this range. So let's set that up. Now I'm doing this all off the cuff, guys, so forgive me. I don't have any of this. I did at one point have it pre-programmed, but remember I said the lights in the other one are broken, so I took it all out. That's okay. Okay. So what we need is a range. I might want to use a lerp function for this. So, yeah, I think that's what I want to do. Let's go public. We've already got the light. Okay, we don't need that. Okay, so the light dot intensity equals mathf dot lerp. We want to lerp from 0. We want to go to max light intensity. Now here comes the tricky bit. We want to get a number from 0 to 1. Okay. Okay, guys. So there's two things to think about. There's the 0 point and there's the max point, right? The 0 point is going to be when we want when the distance is equal to min light intensity distance. That's when we're going to be at 0, right? Let's do this. Float min distance and float max distance. Remember, we're dealing with square magnitudes, so the min distance is going to be equal to the min light intensity distance squared. max distance, and actually these are never going to change. I don't need to do this right here, but that's all right. Max distance is going to be equal to, okay, this guy right here squared. Right. That's going to be your range. So let's go float range. Range equals min distance minus max distance. These terms are a little bit confusing because min distance means minimum refers to the light intensity, but it's actually going to be a greater distance than this distance. It's the max and min don't refer to the distance, they refer to the light intensity. That is confusing, I have to admit. But we've got a range. So I think we're good if we have a range. So we just need to do distance minus max distance. So that's going to be your shortest range, right? Divided by range. Okay, let's think about this for a second, guys. We have a distance from the camera. Now remember, the distance is a square. We have a max distance, which is also a square, the maximum intensity of the light. So if you're at that distance, say, which is, let's just put in some numbers, 5. 5 minus 5 is 0. And that's going to equal 0, and that's going to make it 0. That's the wrong way, isn't it? The max distance is going to be the shorter one. So we need to invert this, actually. All right, so that's no problem. We can invert it. 1.0f minus. Okay. Let's try that again. So 5. So say the distance is 5, and that's the distance at which the light is at its maximum. Okay, it's 5. 5 minus 5 is 0. 0 divided by the range is going to be 0, and that'll be 1. And that'll give you the max light intensity. Okay. If that number goes lower than 5, say we go to 4 minus 5, that gives you a negative number. So if it's below the max distance, if the distance is less than the max distance, this will floor it, or this will cap at 1, and you'll get your max light intensity. That's what we want. If, okay, so let's say the minimum light distance, which say is 10, and we're at 10. So 10 minus 10 would be, sorry, 10 minus 5 would be, 10 minus 5 would be 5 divided by the range. And we said the range was 5. Min distance minus max distance, that would be 1. 1 minus 1 is 0. That would give you 0. Okay, I think that's going to work. Let's find out. Let's not hit the wrong button. Come on, Unity. Okay. Let's take a look at those lights. I can see they're coming on. They're kind of flickering. Okay, let's give ourselves a ridiculous number here. 0.45. Let's run that. Now the lights are flickering on and off. Oh, you know why. I know why. Because on the trigger, I did this. We want to turn off these ranges. We don't want that on there anymore. Okay. Let's back off the slide. It doesn't look like it's working. Okay. Okay. That's fine. That's fine. You know what? You know the reason I've got the wrong thing in here. We want range, not intensity. Let's try that. The range should be 0. Intensity should flip around a little bit. The range on you is not working. Hey guys. Okay, welcome back. I had to do a quick bit of debugging, but ultimately I think I fixed the issues that we were having. I've discovered that for whatever reason, I'm not entirely sure why, but our prefab torch will not take a value into the camera. It just won't do it. I've tried various ways of getting this to go in here. You can see it just won't go in. And even if I go down to the prefab here, the FPS controller, this guy right here, it says it'll take it. Well, let's give it a quick try. Let me change my script. It says it's taking it, but in my experience, it's not. Let's see if that works. Oh, I've got that sound on again. Sorry, guys. Here, I'm gonna just turn that off. Well, actually, you may still be hearing it. Okay, that does seem to be working. All right, that's good. Maybe I was just grabbing the wrong thing. So, where's my cursor? So yeah, you can't pull an instance of an object into a prefab, and for whatever reason I can't even pull it into an instance and then apply it. It just won't do it. But apparently you can pull a prefab instance into a prefab as a reference. The other way I was doing it was to just go into the start function and do the camera equals camera.main, which also works, but it's preferably not to have that start function in there. Okay, so that's the change that I made. The other thing I have noticed is that the radius that we're working with here, if I take this torch right here and I take a look at them, I've moved all these things. I don't know if I'm gonna have this on camera or not, but just as a debugging aid, I've moved all these variables into public so I can watch them. Take a look at the distance. Now I've got this torch right here selected. I think I've got that torch selected, right? Yeah. Yes, that's the torch I've got selected. Now you remember when I set the range of the radius, I set it to 40 initially, and it was just huge. It was the entire scene. Well, look at where we're at right now. The distance is 34, and I'm sitting right next to the torch. So these are clearly on different scales. So I can't use the radius of the trigger to set that distance. It's not going to work. So this radius I got set to 0.5, which is, you know, this green thing, right? But clearly that's not the same scale as what we had here, where I'm sitting right here next to the camera and I've already got a radius of 40. So they're different. That's basically what I'm getting at. So for this particular light, I've set the light max intensity range to 15 and the minimum intensity to 40. And if you look, let's see, we're currently at a distance of 25. So if I pull in, what's my distance, 17? Right about here it should stop brightening. Now that's too close, okay? But it gives us an idea. You can see if you watch this light right back in here, you can see it's getting dimmer as we're getting stuff in the way, but as we back off it gets dimmer and dimmer, which is what we want. Okay, and you can see the other lights doing the same thing. That's exactly the effect that we're after. Now it's too obvious because we've got it set too low, the ranges, and really if we want to really get technical, probably right about here-ish. So what's our current distance? Is about 408, about 500 is where we want to set our max light intensity distance. And then we'll set the minimum light intensity distance to something like 2000. Okay? Let's see what that gives us. Whoops. Sorry. Let's revert that. I hit the wrong. Okay. The max light intensity distance we want about 500. The minimum light, let's go about 2000. We don't want to mess with the maximum light intensity right now. Now remember, this is just this one torch. So if you watch the distance. You know what, guys? Actually, that's not entirely true. Let's change some of the names of our variables here. Because this distance is actually the square distance. So just so we don't get confused, that's the square distance, right? Let's go ahead and rename that. Because the number we're setting in here is actually getting squared itself. So we're setting that too high, basically is what I'm saying. So when that distance number equals, say, roughly 500, okay, that's what we've decided. So if I take the square root of 500, that's a distance of about 22. So let's say 25 as a nice number. That seems a little more reasonable. And then let's go ahead and run that. So 25 times 25 is what? 625. So anytime we're within 625 as a square distance for this, and now it's messed up again. Oh, you are just killing me. Alright guys, this is the problem I keep having. For whatever reason, the camera just does not want to stay put. And this is what keeps happening. So, okay, I'm gonna go to the prefab. I had this fixed. Go to the prefab. I'm gonna go torch. I'm gonna turn this off. I don't know why, but it just does not want to stay put. So I don't know if we got a bug in there, if there's a script going haywire, but I'm gonna put it in here. Public start the camera equals camera dot void. All right, that should fix it. Let's let Unity get itself set. Okay, is it working? One would hope. Let's make sure we got the right camera or the right torch selected. There we go. Yeah, I don't know what's going on with that, guys. Something's wrong with the... I think I've got a feeling what the first-person camera script is not playing nicely with some of the other... with my scripts. Okay, anyway. So what do we say? 625? So right about here, that's going to be the maximum intensity of the light. Okay, it's not going to go up past that point. But past that, as you drop off, now we said what, 2000? It should drop down. Stuff keeps getting in my way. 2000 is probably too high. Let's take the square root of 2000, which is about 44, 45. Seems a little low, but let's try 50. So again, right about here, and then it should start dropping off. You see it's dropping off. So there you go. It's working fine. Okay. I'm going to take that torch and I'm going to apply those settings to the rest of the torches. Very nice. So now they'll all be set to there. Now you can see, gang, we're kind of fading off in discrete steps. If you watch, that's no good. We don't want that. So let's increase our time, distance check time, or decrease it really to, let's try 0.2 seconds. See how that looks. So 5 times a second it should update. Let's see what we get there. It would be easier if I set these things back down to something low. Yeah, there you go. That's not bad. The number of distance checks is still 73. Let's try 0.1. See what that looks like. Hey guys, so for the last 5 minutes of this video, for whatever reason, Audacity decided to stop recording my commentary. So what I'm doing now is I'm back recording this. So I'm just going to try to more or less recreate what we were talking about. What we're looking at right here is the torch dimming and brightening as we're coming in and out, and it looks like we've got a nice distance time check of 0.01. Okay, we're going to change the maximum intensity because we want to see basically kind of an exaggerated version of this happening, so we make sure everything's working all right. And you can see as we back off, it fades off nicely. It fades back in. And then once you hit the max distance, which is we should be getting close to, if I can see, yeah, we should be getting close. It hits its maximum right there. So yeah, we'll stick that back down to 15, so back down to a normal level, and then we'll apply that to the rest of the torches. Okay guys, so at this point, looks like I'm turning down the volume. We're sitting right now, I think we're looking at the frame rate, and we're sitting at about 60 frames per second, roughly, with this kind of light fade going the way it is. You remember our goal is 200 frames per second. With all the lights on, we hit 50, and with all the distance checks added in, we dropped down to 40. So now we've recovered about another 20 frames per second. So we're sitting at about 60 frames per second on my counter. The other counters looks like it's sitting right around 80 frames per second or so, something like that. It's jumping around a little bit, but yeah. So yeah, this is with roughly 22 lights going, and some of them will be dimmer than others. So we've attenuated the range of the lights based on the distance from the camera, and as you guys remember, as the light range goes down, it hits less things, and for everything that it hits less, that thing has to be drawn one less time. So you know, that's going to end up saving us a lot of draw calls, basically. Currently we're running, what, about 50,000 triangles at this point, which is a reasonable number for this thing. Okay.